Today we are going to look at identities. Remember, x plus y the whole square is equal to what? X square plus 2xy plus y square. Yes, this is an identity, which means that this is always true. This equality is always true for all values of x and y. Similarly, in trigonometry, we have identities. Let's look at the first one. Let's look at a right triangle. Let's say A, B, C. Okay. Now, here, due to Pythagoras theorem, we have AB square is equal to BC square plus AC square. Yes. Now, what we'll do is we will divide each of these terms by AB square. Yes, let's divide it by AB square. Remember, AB square, if we divide it like this, then we can split this fraction into two fractions, BC square by AB square plus AC square by AB square. If you take LCM and add it, you will get back the previous fractions. Now AB square by AB square is 1. Yes. BC square by AB square is what? So if we take angle A, BC square by AB square is equal to, BC square is opposite side, AB square is hypotenuse. So opposite square by hypotenuse square plus AC square is adjacent side by adjacent square by hypotenuse square. Now opposite, this can be written as opposite by hypotenuse. I am just taking you step by step by step. In many books these steps might be skipped. Yes. Now opposite by hypotenuse is what? Sine square. Now naturally we need to give a angle. So let's say this is theta. Angle sine square theta plus adjacent by hypotenuse is cos square theta is equal to 1. So your first identity is cos square theta plus sine square theta equal to 1. Now remember, you don't have to take this angle theta as angle A. You can take B also. Let's say if you had taken B and let's say this is alpha, then in that case BC square by AB square would have been what? BC square by AB square would have been, let's actually do it. We would have this would have been adjacent square by hypotenuse square plus this would have been opposite square by hypotenuse square. Yes. And adjacent by hypotenuse the whole square plus opposite by hypotenuse square, which is cos square theta plus, sorry, not theta, alpha and sine square alpha. So in either case it would have been cos square theta plus sine square theta equal to 1. Okay, the next few identities follows the same pattern, but we start with this identity. Let's say sine square theta plus cos square theta equal to 1. Now let's divide both sides by sine square theta. Right, so sine square theta, sine square theta, sine square theta. Now this gives you what? This gives you 1 plus cos square theta by sin square theta is what? Remember, sin theta by cos theta is tan theta. So reciprocal of that is equal to 1 by sin square theta is cosec square theta. Okay, now let's look at the third one. Now again we start with cos square theta plus sin square theta equal to 1. Now instead of dividing it by sin square theta, we divide it by cos square theta. So let's divide both sides by cos square theta. So what do you end up with? This becomes 1 plus tan square theta equal to 1 by cos square theta is sec square theta. Again, you can take tan square theta to the other side. So you'll end up with sec square theta minus tan square theta equal to 1. Okay. Now apart from this, we have already seen in previous session, sin minus x is equal to minus sin x, cos minus x is equal to cos x, then cos x plus y is equal to cos x cos y minus sin x sin y. Right, please go through the proof of this because this is important. Okay, now cos x minus y is equal to what? Now remember, this can be written as cos x plus minus y. Yes, so using the previous identity, we can write cos x cos minus y minus sin x sin minus y. So now cos x cos minus y is cos y minus sin x sin minus y is minus sin y. Yes, here itself we have done. So which is equal to cos x cos y plus sin x sin y. So this is another identity. Okay, cos pi by 2 minus x. Yes, remember, just now we have seen in the previous identity. So we just substitute the values. So we know cos x minus y equal to cos x cos y plus sin x sin y. So is equal to cos pi by 2 cos x plus sin pi by 2 sin x. Now cos pi by 2 is what? Pi by 2 means 90 degree. So cos 90 is 0. Cos x plus sin pi by 2 is 1 sin x, which is equal to, now this becomes 0 plus sin x, so sin x. So this is another identity you end up with, cos pi by 2 minus x. Okay, now sin pi by 2 minus x. Okay, next one. Now sin pi by 2 minus x. Looks tricky, right? Use the previous identity itself. We know cos pi by 2 minus x equal to sin x. Right? Let's reverse this. So we write sin x is equal to cos pi by 2 minus x. Now here in place of x we write this. So sin pi by 2 minus x is equal to cos. So here this entire thing has to be put where the x is. So here pi by 2 minus pi by 2 minus x, yes, which is equal to cos pi by 2 minus pi by 2 plus x. This and this goes off and you are left with cos x. X plus y is equal to what? What we have seen is cos x plus y and cos x minus y. Here it is sin. So sin x plus y is equal to sin x cos y plus cos x cos y. And that's the identity. But how does it come? Okay. So let's come out with that. Let's derive it. Now from previous identity, what do we have? Sin x plus y can be written as cos pi by 2 minus x plus y. Yes. Now this can be rearranged. Pi by 2 minus x minus y. When we open the bracket, plus into minus minus. Yes. Now we know cos x minus y is what? Again using the identity, right? X minus y. X minus y. So cos x cos y, sin x sin y. So cos x, this whole thing is x here, pi by 2 minus x cos y. So cos y minus sin x sin y. Sin pi by 2, this is pi, minus x sin y. Now this can be written as cos pi by 2 minus x is what? Just now we have proved pi by 2 minus x is sin x. Yes. So sin x cos y. Now sin pi by 2 minus x is what? Minus cos x sin y. Okay. So that's our identity. Similarly, sin x minus y. Just we can take the previous identity and start with that. Remember, this can be written as sin x plus minus y. Yes. So as per the previous identity, sin x cos minus y plus cos x sin minus y. So sin x cos minus y is what? Cos y plus cos x sin minus y is what? Minus sin y. So this becomes sin x cos y minus cos x sin y. Let's see this. We did sin pi by 2 minus x. Let's do sin pi by 2 plus x. Yes, what is that equal to? We already have an identity for sin x plus y, so let's use that. So sin x plus y is sin x cos y cos x sin y. Sin x cos y, here this is x, this is y, from an identity point of view. Okay, and then plus cos pi by 2 sin x. Now sin pi by 2 is what? Sin 90. Sin 90 is 1 cos x plus cos pi by 2 is 0, which means sin pi by 2 plus x is cos x. 13. Same way we can look at minus x. Sin pi by 2 minus x. So sin x cos y minus cos x sin y. Sin pi by 2 is 1 cos x minus 0. So this is cos x. Same way you can do it for pi, right? 180 minus x. So what this means is that you really don't have to mug up or remember all these things by heart. You just have to remember a few of the identities, and the rest you can derive it on the fly. Okay, so cos x minus cos pi sin x. This should not be y, this should be x. Doesn't really matter because it becomes 0, but y variable is not there at all. Okay, anyhow, here sin pi, sin 180 is what? Sin 180 is 0, so this whole thing becomes 0, minus cos pi is minus 1 sin x. So sin x, minus into minus plus 1 sin x. Let's look at cos pi minus x. Right, now remember, cos x minus y is equal to what? Cos x minus y is cos x cos y plus sin x sin y. Okay, cos x cos y sin x sin y. So this is cos x cos y plus sin x sin y, not y, x. Here this is x, this is y. Okay, so cos pi is what? Minus 1 cos x plus sin pi is what? 0 sin x, which is minus cos x. So remembering these identities or being able to derive these identities is very crucial, because using this a lot of problems can be solved easily. Okay, so I think enough for today. Please review this. Please do this on your own as well. Bye for now.